The atmospheric conditions are specified in this tab. These are the atmospheric pressure, the atmospheric dry bulb temperature, and the humidity. The humidity can be specified either by the wet bulb temperature or the relative humidity. The properties of the air can be shown on a psychrometric chart where the humidity ratio is on the vertical axis. This gives the kilogram of water vapor per kilogram of dry air. On the horizontal axis, we have the dry bulb temperature in Celsius. The dashed lines show the lines of constant wet bulb temperature, and the curved lines show the relative humidity. The solid line here at the top, that is where the relative humidity is equal to 100%, and it goes all the way to 0% at the bottom. When the air is saturated with water vapor, the humidity ratio is 100%, and on this line is the wet bulb temperature equal to the dry bulb temperature. And as you change the inputs, it will change the state of the air on the graph. So here we change it from, let's say, 25 for the wet bulb temperature to 15. If I change that, you can see that the state of the air indicated by this orange dot moves to a wet bulb temperature of 15. Or I can select the relative humidity. If I change the relative humidity, you'll see that cell become active and the air is back to a relative humidity of just over 50. If I make that, for argument's sake, 80, you can see that this dot will move to 80%. Now, this is a great tool to visualize the state of the air, and it's particularly important when visible plumes are problematic, and it's a great tool to analyze visible plume abatement. In the outputs, we will show the outlet properties of the air, and you can then determine if there will be a visible plume that will form for the particular inlet conditions. The air will be in an unsaturated state below the 100% humidity line, and above this line the air will be supersaturated, where any excess water vapor will condense as a fine mist. This graph is a great help in visualizing the state of the air at the inlet of the cooling tower. We'll also calculate the outlet properties of the air, and one can then determine, as we'll later show at the outputs, if a plume will be visible.